Hi, the objective of this fifth video on synthetic division is to study the function compute owner. I'll be using the C language for this tutorial. A link in the description will take you directly to the work page. It is the work page, a wikibook. You must first download the hash file. You can find here the hash file. You can then download the first example, a C file. I try to work with this file. I copy this file into my editor. I copy my file. Perhaps I must verify if I have all the hash file. Yes, I have all the hash file. I save my first example. Synthetic division. The long division of polynomials can involve many steps and be quite cumbersome. Synthetic division is a shortcut that can be used when the divisor is a binomial in the form x minus k, where k is a real number. In the synthetic division, only the coefficients of the polynomial are used in the division process. Can you help me to study the function compute owner? Yes, I can. Alors, in first I try the example. Alors, this is a polynomial. This is the algorithm of owner. In the first line, you can find the coefficient of the polynomial. In the second line, it is a temporary line. And in the third line, you can find the result of the algorithm. The first and the second coefficient give you a polynomial. It is a quotient, and the last value is a remainder. It is a remainder. It is a remainder. I have put here the algorithm of the algorithm of the synthetic division. This is a part of this function. This is a part of this function. Alors, in first we can try the algorithm, and then I explain the function in the second part. Alors, you can find here 3 arrays. Each array have 4 values. Into the 0 column, you find the number of value in this array, 4 value. 1, 2, 3, 4. And in this polynomial is for the coefficient. You can find in this polynomial the coefficient of the polynomial that I want to work. In the second part, in this array, you find a temporary polynomial, and in the third row you can find an array. Into this array you can find the result of the algorithm, the coefficient polynomial and the remainder. Alors, this first line, I copy the first coefficient of this polynomial. This is minus 3, the first minus 3. I put into the first coefficient of PQR. Alors, I copy this value here. Okay, this is the first line. Now I try to go into the for loop. Alors, this value is this value PA0. It is this value, so I put this value here. Alors, I put here. It is this value. I put it. 4 minus 1 is 3. Okay. Now I go into the first line. Alors C equal 1. Alors 1, 1, 1, 1, and 1. C equal 1. Alors, I want to use this value, PQR. This is this value, minus 3, this value. I multiply this value par K. K is minus 1. K is minus 1. Alors, I copie K égale minus 1. OK? Alors, in this line, I multiply minus 3 by K, minus 1. Minus 3 multiplied by, it is 3. The result is 3. And I copy 3, this value, into the temporary line. And 1 plus 1 is 2. 1 plus 1 is 2. Alors, I put in the temporary line 2. I put this value here. Okay. I put this value here. Okay. In first, I multiply PQR, this value minus 3, by K, minus 1, this gives 3, and I copy this value, then PT2. Voilà. 3, PT2. Okay. Now, I try this line. Alors, I take PT2, this value, 3, plus P1, 2, plus minus 20. PA2 is minus 20, PA2 it is minus 20, and PT2 it is 3. Alors, this gives minus 20, no, this gives PT2 donc 3 plus minus 20. This gives minus 17. Okay. This line, this gives minus 17. Z minus 17. and I put this value dans PQR2. Donc PQR2 is here, and I put minus 17. Okay, and now I go into the loop. The loop plus plus, so it is 2 here, 2 here, 2 here, 2 here, 2 here, hola, and 2 here. Okay. Now I put 2 and I have increment the 2. Alors, now this line, alors PQ2 is 2 ici, minus 17 multiplied by k minus 1. Donc, in this line I have minus 17 multiplied par minus 1. This gives 17. Minus 17. And I copy this value, minus 17, dans PT3. PT3. PT3, 17. 17, PT3. Okay? Now, I take PT3, donc 17, plus PA21. Alors, PA3, 4, plus 4. PT3, this value, sorry, this value, PT3, this value, plus PT1, 3. Voilà. This gives 21. Okay? This gives 21, and I put 21 dans PQR3. PQR3 is here, 21. And now I continue. This is increment 3. Is 3 is lesser than 3? No, the algorithm stop. Okay? In fact, this algorithm do the same thing. This algorithm in C language do the same thing. This algorithm by hand. It is the same thing. Okay? This is the result. Alors, you can try to do the you can try to review this video to understand this algorithm. Alors, what is the difference between this algorithm in this page and this algorithm into the function? Alors, you can find here the 2 line, and you can find here the same 2 line here. It is this line and this line is the same. Into the function you have this line. I have added this line. Why? This is the result of the result of the work. Okay. Now, if I erase this line, the algorithm is the same, is correct. I only not write, I'm not able to write the quotient. Now I put the 9. And now I am able to write the quotient. In fact, this line copy the result of the algorithm into the quotient, a polynomial of the quotient. Okay, this line is not a part of the algorithm. It copy only this part of the result into this polynomial. Hop. You have here the quotient, and if I erase this line, I'm not able to write the quotient. Okay. Donc, this is the algorithm, and this is the algorithm that I have erased a line which is not a part of the algorithm. Okay. This value with this line, I can print with this line. I can save the remainder. You can see this is the remainder. I can print the remainder here, and I can print the remainder here. I save here the remainder. This is the function. I save here the remainder, and this is the remainder. If I put 0 here, the remainder is not saved. But the algorithm is correct, but the remainder is 0, because I have put 0 here. If I rewrite the code, the remainder is correct. Okay, and when I erase the remainder here, this not affect the algorithm. Only I am not able to write the remainder alone, but in the remainder it stay correct into the algorithm. Yes. Alors, this is the function of owner. This function only compute the algorithm owner. If you want to print the if you want to print the result, you must use the function print owner. In fact, print owner only print the array PA, PT and PQR. For example, if remember now you can find the algorithm is not executed because I have authorized the command computer owner. Okay, but I write the coefficient of the polynomial, but I do not compute the value of the synthetic division. Why? Because I have authorized this line. Now I put the line. Now it is correct. In fact, this value compute owner compute the algorithm, and print owner print the algorithm. Print owner print the algorithm. It is only loop for who print the array PA, PT temporary and PQ QR. Okay. Alors now I have tried to help you to study the function compute owner. Okay, this is the simplified code of this function. It's too difficult to explain another second tape. Thank you.